Alright, we're going to look at the homework counting atoms. So I want to make sure that you guys understand how to do this. So go ahead, I'm going to give you 30 seconds. I'm going to pause this for 30 seconds. And you are going to read this intro paragraph right here. So go ahead and read. You have 30 seconds. Okay, if we come down here for the first example, we're looking at a chemical equation which it has hydrogen reacting with oxygen to produce water. So we have our reactants on the left side of the arrow. So here's our arrow right here. Everything to the left of that, so on this side, those are my reactants. Everything to the right of the arrow, those are my products. Now, when writing chemical equations, instead of writing out the words, we have chemical symbols that represent the different chemicals. So H2 would be hydrogen, O2 is oxygen, H2O is water. Now today we're going to practice counting atoms. So we want to make sure that we know how many atoms are on each side of the arrow. So here's the arrow right here. So we want to count the atoms on the left side and the atoms on the right side. So we have this box that lays it out for us pretty easily. So what we need to do is count how many atoms there are. So when we first look at hydrogen, we have H2. Now, H2 means that there are two H's, so if we look at this, it's more like this. There's an H bonded to an H. That tells us that we have two hydrogens, so when we count it, we would put two hydrogens. Same thing for the oxygen. In this case, oxygen bonded to itself looks more like this, so that would be two atoms of oxygen, so we have two oxygen atoms. And finally, we have H2O. If we looked at the structure for H2O, we have a hydrogen bonded to an oxygen, bonded to another hydrogen, and that is H2O. So if we look at that based on the picture or based on the structure there, the chemical formula, we know that we have two hydrogens and one oxygen. Even though it's not written, we know that there's only one oxygen right here. We don't have to write it, but we know that even though it's not there, it's one. Now, if you turn the paper over, let's look at one on the back. Because this one will be a little bit more difficult. If we look at this problem right here, and I'm going to focus for now on this molecule. So I'm going to go to a blank screen so that we can see this a little bit better. So we have CuNO3 2. If we have a parentheses followed by a number out here, then everything inside the parentheses is going to get multiplied by the number outside. So let me show you why that happens. If we have copper, this copper is bonded to two of these molecules. So we would have a bond here, let's say NO3, and then we have a bond here, NO3. So that's what's happening, is that copper is bonded to two molecules. But instead of writing both of these out, we're just going to put a 2 here to show it's being multiplied by 2. So the easy way to do this, we take copper, there's only one right there. That 2 only gets multiplied by to the things inside the parentheses. So this copper, there's only one of them. That's by itself. Then the nitrogen, it has a 1 right here. So that 2 gets multiplied by the 1. 2 times 1 equals 2. So from that, we have 2 atoms of nitrogen. And finally, we have oxygen. Each one of these molecules right here has 3 oxygens, but we have 2 molecules of it, so that means that we have 2 times 3, which is 6 atoms of oxygen. So if we counted up all the atoms, it has 1 copper, 2 nitrogens, 6 oxygens. If we look back at our structure, we can count them up. We see 1 copper there, we see 2 nitrogens here, and then we have 3 oxygens here, 3 oxygens here, for a total of 6 oxygens. Now on this next page, we're going to investigate the difference between atoms and molecules. So if we look at picture A, individual atoms are right here. So these are all my atoms, single atoms. Now these are also atoms, So if we counted up all the atoms here, we'd have 1, 2, 3, 4, 5, 6, 7, 8 atoms. So my atoms here equal 8. Now remember, our definition of molecule is when 2 or more atoms are bonded together. So atoms are bonded together. In this case, they show that they are attached to each other. Okay, so that indicates that the atoms are bonded together. So that right there would be one molecule. This right here would be a second molecule. So we have 1, 2 molecules. So in this case, in A, the molecules are equal to 2. So you would go through and do that for each one, A, B, and C. Okay, now that we've gone through this worksheet, go ahead and go back and get started. I will also be posting this video on Edmodo, so if you don't finish it today and you need to finish it at home, then you could go to Edmodo, check this out, and this will help remind you of what to do and how to solve these problems. All right, good luck. Get to work.